Section 3.1, Graphing Equations of the Form y equals mx plus b. All right, the first two chapters in this book had a lot of review in them, a lot of stuff you should have already known. A lot of the stuff in chapter 2 that we just finished with percents and adding and subtracting numbers, multiplying, dividing numbers, or that, all that kind of stuff, I'm guessing you already knew it, had already seen it at least many, many times. Now we're going to move into really the algebra portion of this book. So I think you're going to start finding a lot of new material, a lot of stuff that is going to be harder because it's new. Not that the material itself is hard, but it's new. And anytime you're looking at something new, it's more difficult. All right, so one of the things we're going to do is we're going to spend a lot of time on lines. All of chapter 3, and I think even a bunch of chapter 4 is going to be all about lines and something called linear functions. We're going to start with the first couple sections here in chapter 3 of looking at the basics of graphing. Graphing is a very important skill that students tend to struggle with a lot. So we're going to spend quite a bit of time on graphing. Hopefully by the time this semester is done, you'll feel a lot more comfortable with graphing. All right, so section 3.1 in particular, we're going to graph equations that are in the form y equals mx plus b. So your typical directions, I'm going to give you an equation. It's going to say graph y equals 2x minus 3 and determine the y-intercept. And determine the y-intercept. And we'll talk about what that means here in just a second. Okay, well, I'm going to graph. So when I'm going to graph, I'm going to have a grid, graphing grid, like so. This is called the plane, or more particularly, the Cartesian plane, named after the famous mathematician René Descartes, who first started doing something like this. And over here, I'm going to build a little table. And what we're going to do to graph is we're going to find some points that sit on this line. Our graph is going to be a line. All the graphs for a while are going to be lines. So if you get anything that you're graphing and it's not a line, you've made a mistake somewhere. But my general rule is if I'm going to graph, I'm going to build a little table here. I should plug in a couple positive numbers. I should plug in a couple negative numbers. And I should plug in 0. So I'm going to pick a couple positive numbers. I'm going to pick 3 and 1. I'm going to use 0. And I'm going to use a couple negative numbers. I'll just go with -1 and -2, I guess. All right, so I'm going to plug these numbers in for x. So I picked 5 x numbers that I like. I'm going to plug each one of them in, and that's going to give me 5 y numbers. So if I plug in 3, I get 2 times 3 minus 3. That's 6 minus 3, which is 3. Plug in 1. I get 2 times 1 minus 3. That's 2 minus 3. That's -1. Plug in 0. 0 is my favorite number to plug in, by the way. It's always the easiest one. I get 2 times 0 minus 3. That's 0 minus 3, which is -3. Now, be careful when you plug in negative numbers. Again, like I talked about before, when I plug in numbers, in particular negative numbers, it's always a good idea to use parentheses. So I'd write this as 2 times -1 minus 3. That's -2 minus 3, which is -5. And finally, 2 times -2 minus 3, -4 minus 3, which is -7. All right, now I have to determine a scale for my axes. And the way we scale these, this horizontal axis, this one always has the x numbers on it. And this vertical axis always has the y numbers on it. So I notice my x numbers, I have a low of -2 and a high of 3. I can just go by ones here, I think. 1, 2, 3, -1, -2, -3, like so. And my y numbers, I have a high of 3 and a low of -7. Oh, I can probably still go by ones. 1, 2, 3. 1, 2, 3. Can make my thing a little longer here. 4, 5, 6, 7. So -3, -6. Oops. 6 would be there. Now, notice I didn't put a number at every single little tick mark. You don't need to. I did on the x-axis, but not the y-axis. You just need to put enough numbers on your tick marks so that the reader of the graph has an idea of what your scaling is. All right, so now we mark these points. So I'm going to start at the bottom here. X is -2, y is -7. So I start here at the origin, and that's where the two lines cross. And I go left 2 because my x is -2, so there's -2, and then down 7. So -2, -7 would be this point right here. Notice we always write the x number first and the y number second, and the number on the left tells you left and right. The number on the right tells you the up and down. Okay, so my next one, I got x is -1, y is -5. So x is -1, y is -5. That's right about there where I goofed up and I crossed that thing out. So I'll just put a dot there, -1, -5. Now, it's not required that you label all these points, -2, -7, -1, 5. I was just labeling them for those of you who may not have seen graphing before and weren't quite familiar with it. All right, x is 0, y is -3. That one's right there. X being 0 means we don't move left and right at all. We just go straight down 3. 1, -1. 1, -1 means I start at the origin. I go right 1 and down 1. That's right there, right on top of where I wrote the number 1. And finally 3, 3. So 3 to the right, 3 up. That's right there. Now, if I've done it all correctly, which I think I have here, my dots should fall into a nice straight line. Now, you'll notice mine are close, not exact. That happens, especially when I'm not using graph paper and I haven't used a ruler for anything. But I'm going to make it come out as good as I can, I suppose. Looks like so. There's my line. Now, it asked me to determine the y-intercept. The y-intercept is the spot where we cross the y-axis. And you'll notice that we already determined that. The y-intercept is right there. That's the spot where the line crosses the y-axis. So if you use 0 as one of your favorite numbers, which you should because it's the easiest one, you will always find that y-intercept. So there's my suggestion. Okay, let's try another one. How about graph y equals -3/4 x plus 2. All right, same kind of idea. Going to make my axes. And build my table. All right, this time it's a little harder though. And what makes this one a little bit harder is that this number in front of the x is a -3/4. It's a fraction. So you've got to be a little bit clever when you pick your numbers when you have a fraction involved. And let me show you what I mean. I could pick the number 2 for x. There's nothing wrong with the number 2, except it makes the arithmetic kind of hard, because I would have -3/4 times 2 plus 2. And I got to mess with all those fractions. I really don't want to. That's -3/2 plus 2, which would be 1/2. And I'm really not particularly happy with that. I really don't like it when one of my answers comes out to be a fraction. Hard to graph, hard to find that spot on my grid. So we need to be clever here. And by clever, what I mean is we want to pick numbers for x that make that fraction go away. So I think a good number to pick for x would be 4. Because when I use 4, I'm going to have -3/4 times 4 plus 2. That's going to be, the 4's reduce out, I get -3 plus 2, which is -1. The next clever number I think to pick would be 8. So basically, see what I'm doing here, I looked at my bottom was 4. What I'm doing is I'm picking multiples of 4. So I would pick 4, 8, 12, 16, so on and so forth. If I plug in 8, I have -3/4 times 8 plus 2. The 8 and the 4 reduce, I get a 2. -3 times 2 is -6. -6 plus 2 is -4. All right, I would always pick 0. That's always my favorite number. When I pick in 0, this one's why I like 0. It's so easy. Negative 3/4 times 0 is 0. 0 plus 2 is 2. Don't really have to write down any of the work for that one. All right, now a couple of negative numbers. Same idea. I would use negative 4 and negative 8 to make my fractions go away. Negative 3/4 times negative 4 plus 2. The 4's go away. The negatives go away. Negative times negative is positive. So negative 3 times negative 1 is 3. 3 plus 2 is 5. And finally, negative 8, I'd have negative 3/4 times negative 8 plus 2. That reduces to be a negative 2 and a 1. So that's going to be 6 plus 2, which is 8. All right, so now my axes now, this time I notice on my x-axis I used 4 and 8, negative 4 and negative 8. I'd go by 4s. So I'm going to put 4, 8, negative 4, negative 8. On my y-axis, I've got negative 1, negative 4, 2, 5, and 8. I guess I'll go by 1s again. 1, 2, 3, 4, 5, 6, 7, 8. Although I'm only going to label the 4s and the 8s. And then 1, 2, 3, 4, 5, 6, 7, 8. Negative 4, negative 8. All right, so I have x is 4, y is negative 1. 4, negative 1, right about there. Keep covering up my own numbers here. 8, negative 4. 8, negative 4. 0, 2, right there. Negative 4, 5. So negative 4, 4 to the left. 5 up. Right there. And finally, negative 8, 8. 8 to the left, 8 up. Right there. And, well, you know, it kind of looks like a line. Kind of doesn't, though. Again, I think it's just because my stuff isn't very straight here. Don't know what else it could be. So, let's connect our dots best we can and make a line. Okay, so again, ooh, boy, I missed one badly there, didn't I? See, here's what you do when you miss badly. You cheat and you make your dot bigger. All right, so again, my line isn't very straight, but again, it's because I didn't use a ruler. My tick marks are not evenly spaced like they should be. Use a graph paper, use a ruler. Your graphs will come out looking much nicer than mine just did.